So when you first glance at UGC on 13397, it looks, well, pretty standard, right? Just another spiral galaxy out there in Lyra.
Beautiful arms, those dark dust lanes. It looks quite serene.
Exactly. And the light we're seeing, it left 250 million years ago. But we know with Hubble, looks can be deceiving. There's often something more going on beneath the surface.
That's definitely the case here.
So today, we're going to dig into UGC 13397. Our mission is really to, look past those glowing arms using Hubble's data and find out what's happening deep inside its core.
Yeah, let's get into it.
It seems so calm from the outside. But what's the big surprise hiding in there?
Well, that's the fascinating part, isn't it? That contrast. You see this graceful spiral, but the real sort of drama, it's all happening right at the center.
Okay.
The peaceful view, it completely hides this incredibly active heart, a real powerhouse.
An active heart. So what is that? What's the engine driving all this activity that we can't just, see easily?
Okay, so deep inside, there's this truly enormous supermassive black hole. And I mean enormous, about 174 million times heavier than our sun.
Wow, 174 million. That's hard to even imagine.
It really is. And it's not quiet, it's actively feeding. Think of it like a cosmic engine pulling in gas, dust, even whole stars that get too close.
Yikes.
And as that material spirals in, it gets incredibly hot, incredibly energetic. It releases just vast amounts of energy across the whole spectrum. We're talking X-rays, other high-energy stuff.
So it's lighting up, just not necessarily in ways our eyes can see easily because of all the galactic stuff around it, like dust.
Precisely. A lot of thick dust clouds block our view in normal visible light, but those really powerful X-rays, they can punch right through that dusty shroud.
Ah, okay. So the X-rays are like a beacon cutting through the fog.
Exactly. And that X-ray signal is crucial. It's how we know this is what astronomers call a Type 2 Seyfert Galaxy.
A Type 2 Seyfert. What does that classification tell us specifically?
It basically means that the really bright active nucleus, the supermassive black hole feeding, is hidden from our direct line of sight. It's obscured by, well, a thick donut-shaped ring of dust and gas.
So the X-rays escaping tell us the engine is on, even if we can't see the engine itself directly in visible light.
You got it. It allows us to identify and study these active galactic nuclei, these AGNs, even when they're playing hide-and-seek behind all that dust.
Okay, this is fascinating science, but let's connect it back for everyone listening. Why is digging into a galaxy like UGC 13397 uncovering this hidden drama? Why is that important for, us? What's the bigger takeaway?
Right, good question. It's more than just cataloging another galaxy. Studying systems like this with Hubble gives us really valuable pieces of a much larger puzzle.
Okay, like what kind of puzzle pieces?
Well, for one, it helps us figure out the masses of nearby supermassive black holes more accurately. And understanding their mass helps us understand how these colossal objects grew so huge, especially back in the early universe.
Ah, so it connects to the history of the cosmos.
Exactly. It informs our models of galaxy evolution. How did galaxies, including ours, get to be the way they are? These active cores play a huge role, and we can even study how stars manage to form in these really extreme environments right near the galactic center. It pushes our understanding of, well, the fundamental processes shaping the universe.
So it started as just another pretty spiral, UGC 11397, but the deep dive reveals this hidden monster, a supermassive black hole, furiously feeding, making it a Type 2 Seyfert Galaxy.
It's a fantastic reminder that the universe is full of secrets, things happening just beyond what we can immediately see.
Definitely more than meets the eye. It really makes you wonder, doesn't it?
It does. How many other galaxies out there have these hidden dramas playing out? Unseen, invisible light just waiting for us to find the right way, the right wavelength to uncover their stories.